Uber. So at Uber, for example, every outage where riders couldn't take a trip, they would call it an L5. So that means basically you can't take a trip on Uber. And so I was one time on an L5. I wasn't the commander on it, but I was part of it, where there was this experimentation service that either returns control or treatment. And so this service started returning, well, we knew after, but basically this service started returning everything in control. And so, but before we knew that, the person leading the outages was there's like an art in staying calm, in summarizing what's happening. Because you know the app is not working, you're under an incredible stress because you're losing maybe tens of millions of dollars every minute, if not more. And you have to bring it back on again. And so basically there's this art of staying calm, of bringing everyone that needs to be in the room and summarizing, and just like really kind of you go into robotic mode where you say, okay, this is what we know, this is what we don't know, and kind of basically delegating some of those tasks.
Good morning, good afternoon, and good evening, everyone. Thank you very much for joining yet another episode of the Glitch podcast. Today, I have a very special guest. We have Georges El Khoury, who's joining us for this episode. Georges has extensive experience working in big tech. He has started his career at Microsoft, where he spent 4 years approximately working there as a software engineer on multiple projects. Then I think he decided to go solo and kick off his own startup. After that, he joined Uber, where he also worked as a senior software engineer for about 4 years. And then after that, he joined Airbnb. And now I think he is spending also the majority of his time consulting and building up his newsletter. I'm going to drop the link for his newsletter right here. Feel free to subscribe. He has a lot of amazing tidbits and small snippets about his engineering experience across all of these different great companies. Georges, I'm very happy to have you with me today. Thank you very much for taking the time.
Thanks, Bassem. Super excited to do this.
Anything else you want to tell us about your background before we get started with the questions?
No, that's pretty much it.
All right, fantastic. So Anna, I'm very excited, Sarah, to learn about everything you have experienced. And we're going to start by asking you the most fundamental question. Why, in your opinion, does the world in general, right, perceive big tech as references for good engineering and business practices?
It's mostly because it's not definitely true. There's a lot of good engineers now in big tech to start with, but it has to do a lot with their hiring practices. And so usually these employers are highly desirable employers. And so they get a lot of candidates. And so they get also to be a bit picky. And so they go over rigorous interviews, and then basically you go over phone screening, and then maybe you do another phone screenings, and then you do on-site where you go over programming and system designs. And so the idea is that if one of those HR departments or engineering teams gave you an okay, then that's a good signal. So it goes a bit was kind of getting through the interviews, but you know, if you worked at big techs, it doesn't mean automatically you're a good engineer. Just you get a bit of more credibility, and there's a lot of amazing engineers now in big tech too.
Okay, so you think that because the fact that they have good engineers or maybe even top talent, and because they can afford to hire that top talent, that they have good practices? Because I see in the field a lot of people think that like big tech, they mostly have the best engineering practices, which we both know that it's not necessarily true. But do you think that perception is only due because that they can hire the best talent? Do you think it's also related to their performance maybe in the market?
It comes because usually you're at a certain scale. And if you're a small company with 4 or 5 users, you want to take care of those users and you want to give them a great experience. But once you're at a scale of a Google with a Gmail product, for example, you have to keep it up and running. And just to keep it up and running forces you to have good practices. It's mostly driven by the scale and then the amount of users you're driving. And so that automatically puts you in a place where you have to maximize for quality. You have to preserve the value that's been created. And a lot of these practices come from there. And it's kind of, it's self-generating. So you can afford, good engineers. And in software engineering in general, it's the craft that's communicated from one engineer to another. And so that's another reason why you also have this reputation of having good engineering excellence. It's because of that too. It's one, it pushes you from the need of the company to have good practices, so it keeps running. And two, because you get some really good engineers that do the mentoring and then keeps the cycle going.
Okay, very nice. So I'm going to drill a little bit more into that. But first, I want to ask you, did you always work on feature building teams?
I was, yes. Actually, that's accurate. I mostly worked on top of the stack. I didn't do a lot of infra work on my career. And so I was mostly product facing, and that's where I spent the most time in my career.
Mostly front end, back end, or the whole thing?
Mostly back end, but I moved across the stack, but mostly user facing. So I rarely did any infra work. I have a lot of respect for infra and DevOps, and I know how hard it is. But and I'm dealing a bit with that now, and I'm getting a lot of appreciation with that. I'm getting a lot of appreciation to that. But yeah, I was mostly product facing.
Definitely. The people who help us put in the plumbing in place allow the engineers to do the best work, because they can either make your experience really good or really horrible. So they have a lot of power when it comes to infrastructure.
Yeah, exactly. At Uber, we had a portal where you click a button, you got 50 machines. And at Airbnb, it was a configuration. So yes.
It changes, huh? All right. So out of all of the places where you worked, right? So Microsoft, Uber, Airbnb, and I know this is going to be a tricky question. Which team had the most mature software development lifecycle? When I say software development lifecycle, I'm referring to basically how they write code and how they publish code, and how they maintain good quality code. So which one of these places had the most mature environment?
So I have a lot of friends in a lot of these companies, so I'm not gonna and it's like everything in computer science, it's a trade-off. So basically at Airbnb, they had this very mature environment. They had a mono repo where you can upgrade a library, upgrades everywhere. They had kind of consistent, every microservices had kind of the same pattern. So you can pick any service and then go and kind of be comfortable with it. They had this system where you can kind of see all the services that calls you and all the service you're calling, and if anyone is down, you can see which one is down. They had a good internal search library where basically you can really search. They did a really good job with that, and especially during the COVID years. Like, it's very easy to discover documentation and things like that. They have a Medium article on that. That's pretty good. At Uber, it's completely different. Like, for example, at Airbnb, not everyone wakes up and decide to book a trip at the same time to Paris. Where at Uber, if it starts raining in New York, you suddenly get a surge. And so it's a completely different problem, completely different dynamics. Things are way more real time. And you can also see a bit the difference. Uber is a mobile first company. So there was an incredibly mature mobile team with plugins. So you can automatically turn things on and off on the mobile experience. And so you can also feel that Uber started as a mobile first company, where Airbnb didn't start as a mobile first. So a bit of a difference because of the business itself, and so that's kind of the difference. So both had different needs and different requirements, but so yeah, that's basically it. And I spend way more time at Uber, so I can talk a bit more about that than Airbnb.
Sounds good. So I want to focus on the maturity of their capabilities. So, for example, Out of the two companies that you just mentioned, which company did you feel like it was faster to be able to publish features, for example, end to end, right? So from idea to production, which place was, let's say, more performant or was faster?
Both were pretty agile companies. At Uber was super quick to do an end-to-end. Basically, we would start a feature, we would publish it, we would put it behind an experiment, and then we would go to market with it. And that's pretty exciting. You can see kind of the feedback at it. Airbnb also were pretty quick. So really both had a good appreciation for velocity and engineering. So wouldn't pick any one of them specifically.
Were you delivering like multiple times a day, multiple times a week? What was the cadence of your deliveries?
So at Uber, I'll go for Uber more specifically. I worked on a team called Uber for Business, and you can basically literally ship a feature, and you would publish it, and then that's it. It's live. So we could do that multiple times a day. I didn't work a lot on the mobile side, but basically you can build a mobile feature, and then you get basically the first cut and then the second cut, and then it's in the App Store. My second team, so that was Uber for Business. My second team was Marketplace, and so we would run things. We would run things behind experiments. So you would start an experiment, and everyone would start in the beginning being in control, and then little by little you would move move a little bit of users to treatment, and see basically if it makes if users are happy with it, or if it makes the marketplace be in a better shape. And so this was kind of the process behind things. And if it's a successful feature for the marketplace, and if the users likes it, you would basically go to 100%.
Fantastic. How was this?
So you could ship multiple times. You had to gate it by your configuration, but basically, yeah, you could ship multiple times. Just, of course, if you're working on mobile and you have bits on mobile, then you have to wait a bit more.
By configuration, you mean feature flags?
Feature flags, yeah. Okay. Either feature flags or experimentation.
Got it.
Experiments.
So A/B testing type of thing?
Exactly. Yeah.
Okay, clear. I want to talk a little bit about the team before we dig more deeper into the tech and the pipelines. But how were the teams structured for both of these teams you worked on? Like, for example, what was their size? Were they cross-functional? Was everyone on them full stack, or was just like maybe the teams were just back end? What can you tell me about?
The teams were. I've seen the most success, and the teams were, you had front end and back end, because usually it's a bit of a different skill, and you can do a lot of back end work, and you design the API, and it's usually different repos, and then you can do the front end work, and it needs like additional skills. So it's incredibly hard to be an expert in both, in my opinion. So. In the front end, you're optimizing for different things, for elegance, and it's a completely different set of tools. If you're doing web front end, then you go over React, and it's completely different tooling and testing and skills. And then it's the same on the back end. So usually a feature team would be a front end engineer, a back end engineer, an engineering manager, and a product manager, and sometimes also a designer.
Okay,
designers wouldn't be in the day-to-day, usually, from what I've seen. Sometimes they will, actually. It depends from team to team. But that's mostly kind of the core team. And then this team is independent. And so they can basically execute without needing any help from the outside world. The front-end engineer can take care of most of the front-end work. Back-end can take care of basically everything related to back-end. And the product manager is defining the features and helping out with basically the roadmap, and the engineering manager is kind of driving the whole process. And that's basically how it was. And usually kind of good collaboration between a back-end engineer and front-end engineer is incredibly important to the health of of the team and the ability to deliver features. And so usually you kind of agree on interfaces between the API and between the front end and the back end on certain APIs, and then you deliver on them, and you get things working from the back end on the APIs, and you put the front end, and then there are different challenges on them, and they require different engineering skills, and that's another reason. It's not only the tool set; it's just like a different challenges there, how you design things, and so yeah, but
Okay.
a good team collaborations between the different people in those different roles are incredibly important.
Perfect. That's always essential. And we're going to brush a little bit on that when we talk about collaboration in between teams and features that touch many of these cross-functional or feature teams. But first, I want to talk about how did your team manage infrastructure? So let's say you want to build a feature, but that feature requires that you set up pipelines, for example, for its integration, deployment, so on and so forth. And then maybe you need maybe an extra database, or maybe you need a caching layer that did not exist before. How would you deal with these things?
So at small companies, right, you don't have this problem. You would start, to start with, you'll have only one database, or you would go to your AWS or whatever cloud provider, or Azure or GCP or whatever cloud provider you have, and you would pick everything you need from there. Once you get to bigger companies, usually you interface with other teams. And so you would, if you have a really big service that needs a lot of machines, you get to a sort of an approval from basically higher management or the CTO to explain why you need this much machines, because they will start impacting the budget. And usually there will be a data team for the database, so you'll interface. They usually, in the beginning, they won't have a formal process, so you would just basically try to put things together. And the more mature it is, the more basically they have self-serve, and so you can go and self-serve, and you can see it move from duct taping everything to having a portal where you can request things. And same for the infra, basically. At Uber, we basically had a portal where you can basically pick the number of machines you need and all of that. At Airbnb, there was a really good architecture called One Touch, and it was all configuration based. So in the configuration, you would say, I need these numbers of machines with those configuration, and then go from there. So mostly it's kind of what's really good and bad in working with big tech. The good is you just put a configuration and suddenly you have all the machines that you need. And so it's very decoupled, especially the one that have a couple of years under their belt. So they do a good job in having platform or infra teams and program teams. And it helps everyone. And for the platform and infra team, basically their customers are the program teams. The bad part is a lot of things get abstracted to you, and so you don't get to understand a bit and experience everything that's happening, and that's kind of a big advantage in working in smaller companies.
Did you have a lot of custom tooling in place? For example, did you use Git or did you use something else? Where did you host? I know you cannot really talk a lot about the details sometimes, because of NDAs and whatnot, but as much as you can, did you have a lot of custom tooling in place? How did you do continuous integration, for example? Your unit tests, did they run in the traditional stuff that we're used to, or was there something specific that these companies have built?
It was pretty standard. We had Git. You whenever you land, you run your unit test, and you make sure you have no errors, and also in the CI/CD they would run again. At Airbnb they had GitHub. At Uber they had Fabricator, and a couple of most of them didn't have integration tests that would trigger, but some of them did. And you had a whole set of observability, making sure that things are up and running, and if anything breaks, usually those observability would trigger. And on top of that, it's kind of general company-wide observability. And on top of that, you have your own dashboards and metrics and instrumentations to double check that everything is good. Along with basically the rollout and and basically the feature gating that we talked to about. So pretty standard. Your unit test would run on check-ins, along with basically any linters and anything like that. A couple of services that I worked on had 100% code coverage. So there's also the coverage part. And then after that, it will be live, and then it's up to you to monitor it and see how it goes. But yeah, there was a lot of investment in observability and monitoring and all of that.
And we're going to get to that in a bit. But first, regarding tests, for example, like how deep did you go with your testing strategies? Was it unit testing? Did you even go to integration testing level, for example? Did you do more involved testing, or just unit was sufficient?
So it was mostly unit. You would build your feature and you put the unit tests. And it's not like the end-to-end integration type of testing. There were specific teams that used to do these kind of things, and they would do kind of the end-to-end. The problem was it could be very valuable to have integration tests. The problem is it sometimes it starts giving false positives, and so and if you have if you're just pushing features, and every time you get this integration test, first, that takes a lot of time, and two, that's not super reliable. It frustrates a lot of the engineers. So there's a kind of a trade-off between the value in terms of quality, between of like not breaking things down, versus basically velocity. It can be done, but it has to be very structurally done, and maybe there's a better place to do this in terms of kind of the overall health system. Because if you have all your dashboards and all of your monitoring in place, then basically that would take that could be
just test in production basically, and then observe it.
Yeah, you know, at one time it has to go to production, but yeah, you can maybe catch it before. Also, the rollout strategy can make a big difference there. And so instead of testing in production, you can start, usually you roll out into like a little canary city.
Yeah.
And so you can start in a little city, see how it goes there. The worst it can impact there is 50 people. Then you increase that a bit, then you go for one data center, then you go for another data center. Yeah, it can work. If it's stable enough, integration tests could be awesome. It gives you this kind of really a good, like a self-assurance that things are okay. But if it takes a lot of time, and then every push that you're doing now is a 30-minute to get it on main, and that could be annoying. So as everything we do, there's always trade-offs.
Makes sense. Perfect. And did you have traditional quality assurance teams or none at all?
Not at all. When I started my career, we had it at Microsoft. So there was they used to be called SDET, Software Design Engineer and Test, and I think even now Microsoft doesn't have them anymore. And so none of the places besides Microsoft had kind of traditional QA teams. I'm not a super fan of it personally. It's just whenever you introduce a quality assurance team, you start having this question of who owns quality. Is it the dev that wrote the feature? Is it QA that was supposed to see? And so then you get this question: who's the ultimate person that owns quality? And I've seen it delays delivery of a product or a feature. It basically delays delivery a lot. So the second you introduce a QA, you automatically double your timeline, because a developer will work on the feature, and then QA will test it, and then automatically, without doing anything, you double the timeline. And so it could be useful for very critical flows. It could be useful to have one engineer really trying to break the feature, and could be an incredible return on investments on that. But having systematic QA with every feature team, I think could be counterproductive. I've seen QA doing a great work in building infra testing, and so kind of making it easier for everyone to test, and and adding kind of little test tools on the CI/CD, and introducing tooling there. Would be stories, for example, on the front ends, and then kind of introducing testing part of the development process. Could be incredibly useful. But yeah, it also depends on the product, right? If you're working on something that's super critical, medical devices, then by all means you need QA. But most of the times, maybe it can become quite basically the pros, the cons far exceeds the pros, and I've seen it. I've seen this happening, especially early on in my career in Microsoft. And then they don't. I'm pretty sure they don't have it anymore.
Got it. Yeah, that's pretty clear. Also, this is a trend I've been observing in many other places, and I can understand some of the bottlenecks that it introduces. Let's talk about a topic that a lot of engineers hate, which is the on-call rotations.
Yeah.
So what I want to, the best topic ever. How did you handle on-calls on these teams? And did you do post-mortems? And did you draft post-mortem reports, for example?
First, it's just impossible now to do software engineering in this time of age without tackling on calls. So it's so embedded now, the engineering culture in general, and as much as it's just almost impossible to avoid it. And it's starting to become a core tenet of software engineering, especially observability and having a healthy on-call rotation. I've done all of the above. So I've been on outages calls. I led outages call, and I contributed to postmortems, and I also wrote, authored, was the main author on postmortems. And so, yeah, I've done all of the above.
Can you tell me a little bit more about the process of on-call? Like, do you have a pager, or do you have a phone specific for the on-call? How do you get called whenever there's an outage? What really happens? Can you just maybe give us an example scenario?
So usually there's basically the primary on-call engineer, and he's kind of I don't like to say first line of defense because it's kind of too much responsibility. He's kind of the first person to be alerted. And usually this engineer would check, make sure that's a valid alert, check that if there's an outage happening, and basically at this time make a call whether to have an incident or not. And it's a very good practice to encourage engineers to be able to kind of page their secondary on call. So usually it's kind of primary, and if the primary doesn't respond on the on call, it will go to the secondary engineer. And so at that time, they and if there's an incident, usually the person on call is, every company calls it something, but usually is the commander. And so he would be responsible of this outage end to end. And so usually he will make sure that every person that needs to be on the outage call is there, and the engineer will page them too. Usually, most of the company, all of them had pager duty. So I guess it's the favorite company of everyone in the valley, or everyone in the world now. Mm-hmm. And so they will be page on pager duty. And you have to respond, basically. You have to act your alerts. And then starts the fun part of figuring out what's happening. And so sometimes it's clear, and sometimes it's not clear at all. And so you just don't know what's happening. And sometimes you have like second degree impact. And so, for example, I was part of an outage one time at Uber. So at Uber, for example, every outage where riders couldn't take a trip, they would call it an L5. So that means basically you can't take a trip on Uber. And so I was one time on an L5. I wasn't the commander on it, but I was part of it, where there was this experimentation service that either returns control or treatment. And so this service started returning, well, we knew after, but basically this service started returning everything in control. And so, but before we knew that, the person leading the outages was there's like an art in staying calm, in summarizing what's happening, because you know the app is not working. You're under an incredible stress because you're losing maybe tens of millions of dollars every minute, if not more, and you have to bring it back on again. And so basically, there's this art of staying calm, of bringing everyone that needs to be in the room, and summarizing, and just like really kind of you go into robotic mode where you say, okay, this is what we know, this is what we don't know, and kind of basically delegating some of those tasks. And suddenly, bit by bit, you start kind of piecing and understanding a bit more what's happening, and then suddenly you get it, and there's an aha moment. And then you move to the fun part of like, what do we do now? How do we mitigate it? Yeah, how do you mitigate it? And so do you roll back? And there's like a whole thing that you do at this time. You just see what kind of, before this, I'm talking before mitigation, or trying to see what's happening. You go over all the changes. Was anything deployed at that time? Did any configuration change at that time? And then and then you try to really kind of keep going, keep peeling until you find the issue. Once you find it, then it becomes, how do you mitigate it? You roll back. Do you move to a data center? Do you roll over a certain data center, and or just push, just do a fix? Usually, the worst thing you can do is push a fix in the middle of it.
A forward fix, yeah.
The forward fix is almost always not a good idea. And so you usually try as much as possible in this time to roll back, catch your breath, go to sleep, and then next day try to work on the fix. And so yeah, there's the mitigation. And then part of the post-mortem, one of the most healthy thing an engineering organization can do is to bring post-mortems. And you don't want to do it for every bug. That becomes a bug, not a post-mortem. But any huge incident that impacts the mission of a company, a post-mortem will be incredibly good. And it's costly, right? You're stopping everything you're doing, now working on features, you're not fixing bugs, and it's very disruptive. But usually the returns you get on it is tremendous. And so you go over kind of a summary of the outage, you go over the timeline, and then you go over basically how it was discovered first. Did we discover it through automated alerts? Was it manual? Was it like a user somewhere in the part of the world? Was it through support? And you want it as much as possible to be through alerts where the engineering organization knows about it before anyone else in the world, if possible. And then you move basically how it was mitigated. How could we have mitigated it better? And the last step will be prevention. So what do we need to do in our architecture to make sure these kind of things don't happen again? And usually it means introducing redundancies or doing things a bit differently. But yeah, a lot of fun.
Fantastic. This has been a great narration of the whole journey end to end, and you definitely touched on pretty much all of the important points about how on-calls happen, incidents happen, incident management, root cause analysis, post-mortems. That was fantastic. Thank you for that. One more thing I want to ask is about the on-call rotations. How frequently did they happen? Was it like one day a month, or was it more of a 1 week a quarter? Or
every company and team does it differently. My favorite is a week, or either a couple of days or a week, because this way you can just be the on-call person. Know that you won't have the best team ever, the best week ever, and be done with it until it happens again.
Okay.
And again, on-calls are such an important topic now that it plays a big role into the health of an engineering team and organization. So, for example, if a team has a noisy on-call, where the second it's always ringing, and it's just awful. It's just awful. No, everyone is waking up at night.
Yeah.
A lot of time there's no outages. Not a lot of time. Most of the times, if not every time. And what happens is even more dangerous. Is just like people stop taking those alerts seriously. So you would be having lunch, and your pager duty will trigger and be, oh, that's not a biggie. And so it's just really bad. And usually in this case, you want to stop everything, literally everything, and make sure you go for 1 or 2 or 3 days without any outage. And it needs a lot of discipline to really keep it like this, and then keep fine-tuning until you have a healthy monitoring. That being said, if you get to the state, it's super awesome. Because now, the second it triggers, you have an outage, you already have your dashboards, and it's just like, and ideally, the outages don't happen every day, right? So ideally, in an ideal state, and teams should strive to get there, because otherwise it's incredibly disruptive. You should have most of your on-call rotations with no incidents, and ideally. Alerts, exactly. Ideally, alerts equal outage.
Yeah.
And then that's really good. And then the CI/CD and the stuff that you have in place, the quality assurance, the rollout also shouldn't be a surprise. If you rolled out bit by bit, then it shouldn't be a surprise. All of this play a big role. But yeah, outages will happen from time to time. And having a good culture around that is also useful.
Definitely. This is a gigantic topic, because we can talk for hours about like what is the balance, what is striking the balance between having enough alerts and for these alerts to be meaningful. A lot of companies start by having an abundance of alerts for everything pretty much, and that's just noise. You really want the signal, you really want as you just mentioned, like an alert should mean an actual incident where people need to attend to. Otherwise, people just completely dismiss them. That's fantastic.
Exactly. Every then and while, you would land on a very high quality alert. Every company has it, and once you find that, it's like a holy grail. And so you would know that basically, if that one triggers, you would know there's an outage, and usually it's a good metric that summarizes a very complicated engineering system, but there's this like one metric that kind of really is a good status about the system. And yeah, once you find this, it's awesome, and it's just a lot of value. It's hard to find, but once you find it, it's just great.
Fantastic. All right, let's switch gears a little bit and let's talk about architecture, right? So feature teams, great. There's a product manager, they came up with a feature, but that feature requires some design, right? Like it's not as simple as adding a button somewhere. It's more evolved than that, so on and so forth. Who deals with the architecture on the teams that you worked with? Is it the senior engineers? Do you have architects maybe? How was it done?
I almost never had architects, so it was very much the engineer is responsible of the feature, and so it depends on every feature. It depends whether basically it's mostly the engineer responsible of the architecture, and the feature would come in either from a product manager, or a lot of times it comes from the engineers themselves, and it's kind of a bottom to top. And so it's usually something they want to build, or something that they think will create value, or something on their backlog. And sometimes also it's a company initiative or a priority. And so one day you would wake up and there's like this huge priority, and they would usually get people from all over the company to kind of deliver on it. So it comes from either top to bottom, depends on the companies. Some companies more than others. Or it could be bottom to top, and those usually are very healthy teams, because folks are close to the code and to the problems. And sometimes it comes from the product organization, and so it comes from those three places. And so then there'll be a team that will be formed and responsible to delivering that. And usually the engineer would be responsible of designing it. and I've seen entry-level engineers design a feature, and then it could be up to all the levels of the engineering organization. And so usually they write a little product called ERD, engineering requirement design. I forgot, and so they will kind of explain how they're gonna go about it. The biggest value is documenting it and also kind of what we consider. So a really good way of a good RD will say, this is what we're doing. We looked over option 2, 3, and 4, but we decided to do this because of those reasons. So anyone reading it would understand the thinking behind this feature. And so, yeah, it doesn't have to be elaborate, it has to be pretty concise. And then we go into the day-to-day of feature implementations.
And did you maintain these ERDs or ARDs, architecture with design records or whatever, to reflect the as-built? Because sometimes you design something, but then as you're building it, you discover, like you have to do some tweaks. Did you re-update them to reflect?
No, I always go out of date. I've seen people trying to keep them up to date, and the source of truth is always the code. And they will go out of date, and so usually they're valuable. They reflect the thinking, and a lot of times they are accurate enough. Yeah, sometimes they change. If they change completely, usually people will say deprecated or something like that. But in the end, the source of truth is the code and the actual architecture flow in production, which service are calling which service. And that's the only place to get source of truth, and it's incredibly hard to document it. There's a lot of effort that's been done into having self-documenting flows, and where basically you click on a service, you see all the service that calls it and all the service that they call, and that's awesome. That's actually really great. But yeah, those ERDs will be outdated, and so but they're also super valuable because they explain everything in a good way.
Georges, how was the relationship between different teams? So again, let's say we have a feature that touches multiple feature teams, right? You want to build something and you need the collaboration and help from other teams, for example, to build stuff on their end. How was this coordinated? Did the engineers go by themselves, talk to the other team? Was it handled on the product management level or the engineering management? How was it done?
Usually it's done in this ERD. So that's kind of one of the purpose of it, is to align as many people as possible. So it's not only explaining the options, as I said, and then how it's being built. It's also to align all the teams on it. And usually everyone that's impacted by the feature, whether whether basically you're calling downstream or upstream, there will be reviewers on this ERD, and they will need to be they need to approve it. And so a big part of the alignment happens through the ERD and getting everyone on the same page. And it's usually driven by the engineers themselves, at least in the companies I've been with.
Okay, fantastic. That's great. So yeah, the ERD seems to be a great mechanism to bring everyone on board and aligned. It's a great, as you mentioned, a great documentation. Probably not maintained, but it's a great starting point.
And it's basically every team will have their own priorities, and sometimes you have to build something and kind of changes their priorities.
Right.
And so and then you wait for them to, let's just say they're rebuilding things. So you wait for them to finish, and then you build your feature on top of the new stack, but that means you're going to delay your feature. Or you do it now, and then maybe you have to rewrite it when they do the new things. And you get into those little things. And usually you would think that everything is official and everything is there's like a lot of these processes. Mm-hmm. But a lot of time it ends up being basically relationships and friendship in those teams, and then the graphs. And so usually, if you, as an engineer, have built a lot of credibility in the bigger, in the org or in the company,
you have influence,
and then you get passes, not only influence. You get passes, and so teams and team members. Again, it's not kind of teams. It's usually teams are a bunch of people. So engineers will give you passes or will accommodate you, will let you check in. And things like that. And a big part of it is related to credibility. If you're doing a code reviews and and then you get a stamp, but under the condition that you'll come back and fix something. And if you go ahead and come back and fix this thing, you get extra credibility. And that's why people that's been in an organization for a long time are super valuable, because usually they know almost everyone at the company, and they can be great at aligning different teams on the features, or they can be great in having commits where otherwise would have been really hard to do.
These are fantastic insights.
It's people. It's not processes, or it's not teams. It's just like it goes back always to the people.
I mean, isn't that at the core of what Agile is, right? In a sense, like people should not be forced to do something. It should happen just organically. Just like any other relationship we have outside of work, if you just bring that in, also, you know, teams want to benefit, they want to shine, they want to also measure impact, they want to have projects that make them look good, right? So all of these different factors come into play when it comes to prioritization.
Exactly. Also, how much it aligns with what they're up to do, and all of that. Yeah, that's another big important part too. Yeah.
Fantastic. So that's a great segue for me to ask you about prioritization and planning. So like, at which level is it done? Like, do all project managers come together, for example, to talk about what they're going to build for the next quarter or maybe a year? Or is it more agile, like it happens more organically? Are there any so for example, some organizations, they do these PI meetings where they bring everyone together and they discuss what they want to build for the next quarter or two. Did any of this stuff happen where you worked?
It's really company by company. And so every then and while there will be a company priority. So a company will try to target a certain market or a certain product, or they're getting ready for a certain milestone. And so every then and while, it's top to bottom. The CEO will wake up one day and it's like, okay, we need to do this. And then suddenly everyone is doing this. Especially if you end up with like one of the projects that are very important, close to the heart of the CEO, then you know that gets happen. It's top to bottom. Mm-hmm. I've seen also the whole planning and every 3 months we have to do this. I never seen those to be super successful, but they also help. And because every time you have a certain strategy and you want to build features that impacts the strategy, the most healthy way that I've seen is usually on the team level, team or team plus level, or the bigger team. So usually you have your backlog there. It has features, it has bugs, and it has things that the team would think that can move the needle. And then every week you kind of pick what to do or what to tackle. So it's a mixture of both. But usually it's either a market opportunity that the teams want to tackle. A lot of times sometimes, not a lot of times, it's top to bottom, and sometimes it's bottom to up. And and sometimes there's those kind of big quarterly meetings that happens, and there's like a whole discussion over what we're gonna build, and everyone is waiting to see what the result is. And these are not usually the best way to do it, in my opinion.
All right. So on the team level, did you, for example, use the most popular agile ways? Did you use Scrum or Kanban, or was it a variation of the two? What have you seen in these companies you worked for?
Also, I've seen a lot of them, but I'm almost now at a certainty that sprint is not the ideal way to do it. And so I am almost sure there's no value in having estimates. And you go over this whole work of estimating how much it's going to take. And I'm sure someone is going to say this is very valuable and it puts clarity in the roadmap. But you always go doing this exercise, and most of the time you're just kind of buffering and doubling your estimates to over deliver, under promise, and all of that. But so yeah, I've seen all of them. The one that I think works the most is usually in these things, the simpler they are, the better. And if they start exceeding a certain threshold of planning, the good engineers will rebel, will not like it, and so they will push back or they'll be unhappy, and it's usually not good.
So let's say I have a feature. Let's say I'm a product manager. I have a feature. I come to you. We define an epic, like big thing, and then we break it down to smaller stuff. What happens then? You just pick it up and go, and I just look up for your releases, or
the best way that I've seen it work, and I'm kind of at one point in my career that I have a high confidence. That's kind of a really good way to do it. Always keep an open mind on how folks do it. But usually you get a feature and you split it. There's a lot of value in splitting it, no matter what. You split it kind of into little features. You try to make them as little as possible, as atomic, usually 1 unit of work. And then usually you do a stand-up, which is either a daily or Monday, Wednesday, Friday. And basically you would say, hey, I'm working on this part of the big feature. And once you split it, it becomes clear that this is part of the bigger picture. And you just have one board for yourself. Like, it's not with everyone else. You just have it for yourself. And then basically from with one look, you can see all the subtasks and you can see what's done in them, and you can see what you're doing, what you're working on now. And you can also basically see progress. If there's this task that has been there for 2 weeks, then something is not right. And if you're always kind of moving things from the left to the right is done, then things are moving along. That's what matters in the end of the day, it's just having progress.
Yeah.
And so, yeah, and also keeping the feature team small. So when you do a stand-up, don't put a stand-up for the whole organization, where the metric I think from the stand-up, if you're doing a stand-up and if you tune out and if you're not paying attention, that means there's many people at the stand-up. So usually it should be really very small, very focused, the people that definitely are impacted by your work. And yeah, splitting a big task into smaller tasks and making sure there's always progress on it is usually, I've seen it, a good way to do it. Whether you put a deadline or not, another favorite topic of every engineer. I've seen enforcing deadlines and kind of really pushing for them not to be productive, but I've been convinced by managers to put deadlines, and they made sense to me. So I don't have a strong opinion on that. I think a deadline is not definitely my. I had managers convince me that by having a deadline, you just keep everyone focused and driving towards an end goal, which kind of makes a bit of sense. But yeah, having deadline or not is I think per preference.
Got it. Fantastic insights. I 100% agree with what you just said. We can definitely spend an entire episode also breaking this down. And I'm afraid we're getting to the last parts of our session today. The last question I have for you, and it's something I love about GitHub a lot, is we have a concept of trust by default. So we have access to pretty much everything we need to be productive. Have you seen the same thing happen across the different organizations you worked at? What do you think about this?
Yeah, absolutely. So any privacy or trust breach is usually incredibly costly for this company, like incredibly costly. It will impact their reputation. It will impact their bottom line, and so they usually make sure that basically all the systems are properly secured. And so usually, if you need to open up any ticket or if you need to see any. If you basically need to look for any data, you usually have to have a very good business reason to do that. You need a ticket, or you need a Jira ticket, or or permission to do that. And so yeah, usually these things are incredibly important and incredibly well tuned and incredibly well enforced too. So there's any lack of compliance, any basically, if anyone is not compliant, usually there's definitely solid repercussions on that, because they're so important and they can be so impactful. So usually any engineering processes usually mirror business importance, and then so since that is very important and could be very impactful for the company, usually there's processes to guard against that, or to make sure compliance is there.
Perfect. Last question from my end, and thank you again very much for your time. These are fantastic insights. Reflecting back on your career to date, would you change anything? Would you actually go to work for startups as opposed to, working in all of these big companies, or would you just do it the same way?
So I enjoyed it a lot too. Thanks a lot, Bassem. It was an awesome conversation. I think it depends on where you are in your career. And what's really great in computer science is it's just like the field of trade-offs, and basically by making any choice over the other, you pick a certain side of a trade-off. But yeah, early on your career, working on a startup or a mid-level startup, basically a Series C or Series D, is super valuable. But working also with a big company is such a good credibility on your resume that's also super valuable. And it kind of goes back to where we started. And so, yeah, like everything, there's trade-offs. You want to take as much risks, usually early on your career. But then at the big tech, you learn a lot too. There's such a good, they could be very valuable on your resume. And so there's kind of this soul of deciding what you want to prioritize on. And it depends over where you are and what you want to prioritize on and things like that.
Very wise advice. Georges, thank you very much for your time. This has been a great conversation. For everyone listening in, I just want to remind you, Georges has a very fantastic newsletter. Everything we talked about today, he's going to be sharing it in his emails. I'm not sure what's the frequency. You send them once a week or for your newsletter?
I used to do once or twice a week, but now I've been doing maybe once every 2 weeks. But I want to go back to once a week.
Sounds great. Yeah, once a week I think is a good cadence. Again, Georges, thank you very much for your time. Thank you very much, everyone, for listening, and we will catch you next time.
It was a pleasure, Bassem. Thanks a lot.